So we're going to do a run through of the custom task for IMstat. This particular task we built for a budding data scientist with the intention of them being able to calculate price elasticities of demand. So the task is started up and we're on a data tab, but there are a number of other tabs that are available. For instance, statistical tabs, the ability to modify our data, the ability to carry out some model, and also to report. Notice at the moment that reporting is not available until modelling has been completed. There's also an information tab. This information tab gives the user some further information and links through to documentation. So let's go back to our data tab. What we want to do is guide our user through the process. The first thing he's got to do is pick a table from a laser library. If it's not a laser table, let's pick a different table, then it instantly sets two things. One, it sets requirements and gives information in terms of what needs to be chosen, and it also produces the laser return string here. It shows it's a hidden string, so a laser table is a requirement to be able to submit the SAS code. So let's go back and pick our laser table. We're going to take this SAS Global Forum alcohol demand table. On the right hand side you can now see that the code is ready to be submitted. If we actually go up to the little running man and submit it, all we'll get back is just a log window. It's not actually doing anything at the moment. The first things that our data scientists would want to do, maybe they want to have a little look at the table. Now notice that when I click the table info checkbox, it pops up the single table info IMstat word, and it also gives us a little bit of help information. Let's just run that. So what have we got? We've got 36,000 rows, 35 columns, and I owned the data. That's absolutely fine. Let's untick the table info. Let's now have a look at the columns within the table itself. So as it says, the column info statement is used to return information for all the columns in an in-memory table. Here we go. That's useful to us. We can have a look and we can see what do we have within here. I've got things like quantity of beer, I've got hours in employment, and I've also got some seasonal variables plus some geographical data if I required that. So the addition of ability to select the checkboxes pops up individual keywords within the statements within the IMstat procedure. At some point the help might get a little bit annoying, so this particular task has been written in a way that the help comments here, if I untick it, then it will no longer show those. Again, ticking it, though, put the help on. So it's written in a way that it can be a learning tool for the budding data scientists themselves. Now once we've gone past the first elements in terms of just sort of investigating the data, we might want to reset those items. And the way that I've done this, when I click on the little reset button, it resets the checkboxes, including the checkbox at the bottom, and that's done through the dependency statement, with the reset dependency being the last one within that particular item. So once we've looked at the actual structure of the data, we know a little bit about it. Now we want to do things like maybe print some of that data, and printing it is as simple as selecting print records and it will generate a fetch statement, and we can then choose how many we want to print. So by moving the slider, which is surfaced, you can now say, well, let's do 1 to 10. A quick run of that generates for us a dump of the first 10 records within the table, and it's useful because we can sort of eyeball the data, we can have a look at the quantity of beer consumed, we can look at the sort of structure of the information itself. It's typical things that a data scientist would want to be able to do. Again, let's turn off that print statement, we don't need to run it all the time, and let's maybe look at some ranking of that data. Now if we select here, we'll get a top and bottom for 5 values for all variables, but maybe I actually want to look at the price of my on-trade beer, and it generates this top K statement, price of on-trade beer, and I want the top and bottom 10. Let's run that. So what we're seeing here is the highest price £4.53 and the lowest price 34 pence. That's interesting. That's yeah, I might well want to go and find where that where they're selling that particular beer. So that's our rank statement. Let's just remove that. You notice the statement is then removed. We'll minimize a few of these. There we go, just tidy it up a little bit. And then let's do something a little bit more interesting in terms of let's explore the data. Now I know that I've got certain character fields within there, so let's look at some distinct values. How many distinct values? Well, let's look at it from perspective of maybe 12 to start with, and let's run that. So what this is doing is for every single field within there, it's telling me how many distinct values, which is useful because I can see I've got different values for my prices. I've got 129 different regions, and then for each one of those, it's now showing me the groupings of those. So I've got females, males, etc. Anywhere where I've got less than 12 values. Now I know that the mosaic codes had 15. So if I change that to 15, you'll notice that the where n distinct is less than 15 now. I'm putting it into this list, and then I'll generate that list. So we'll just run that again, and what I should get now is the ability to look at that data. There we go. There's my breakdown for my mosaic groups, and I can see the frequency of each one of those. Again, let's just turn off that distinct value calculation. And let's move on now to looking at things from a slightly more statistical point of view. So if I wanted to calculate summary statistics, wow, one statement. Let's run that. Interestingly, it gives me mins, max, number of records, the sum, the mean, the standard deviation, etc. So I can see here that I've got an interesting set of data, and it's so quick at being able to actually just eyeball all of the numeric fields and give me an idea of the values that are there. So let's untick the summary statement. Let's then look at doing something like percentiles, and if we run that, again we'll get for every numeric field the percentile, so I can have a little look at the distribution. And if I wanted to go one step further, then let's produce a histogram. And then let's produce let's choose a variable for the histogram. I want to look at my quantity of beer on trade. I want to look at the distribution of that. Now what I'm doing here is I'm creating the histogram. IMStat itself does not actually create graphical output, so I then use an ODS output statement to create a temporary table, and then I'm using the statistical graphical procedure, the SGPlot procedure, to actually plot that. Let's just run that, and what you'll see here is it calculates the values and calculates my bins, and that's interesting. So I've got, well, what looks to me like two groups. That could well be that there's differences between male and females. I could go back at this point, use my where clause filter. In fact, let's quickly do that. If I apply a where clause, let's have a look at what code it's generating for us. You'll see it's added a where gender equals male. I can also include that as a footnote. So let's just rerun that. So this will only work on males. Let's have a look at the distribution of that now. And suddenly we can see, yeah, that's interesting. Yeah. So maybe it is the males and females that are causing us to have a number of different groups. Okay, let's turn off that histogram statement. You could, of course, also calculate multidimensional data on the fly, so no need to pre-aggregate it, but if I wanted to actually summarize by individual values and maybe group by those values, then I could do it in that way. We also have the opportunity of looking at things from a simple correlation type perspective. So by selecting correlation, it will do a correlation of all of the numeric fields. Let's have a quick look at that. Again, what I'll be looking for is high correlations, quantity of beer on trade. Let's have a quick look at these. Yeah, so we're getting the right sort of, price on trade. It's a negative impact. Price off trade, which would be a competitive product, is a positive sign. So we're getting an understanding of the data itself. But remember our task that we've set our budding data scientists. Let's just reset that. The task that we've set them is that they are to calculate price elasticities of demand. Well, in this scenario, we don't have any log values within the data. So I'm going to pick a transformation. The default here is log. Log is good for elasticity. It gives us our double log model. What variables do I want to transform? So I'm going to pick my price. In fact, I'm going to have all of these variables. You'll notice it now generates a set of compute statements. And we'll run that. Looking in the log, it's created those new variables. Let's go back and remove those because we don't want it to do it again. So a very simple Control A will select all of those, remove those, and the code is then tidied away. So remember, we can't yet report because we haven't produced a model. So if we go back to our model over here, what we might want to do is actually have a little look variable summary wise. What do we have in the way of variables? There we go. That's interesting. Yeah, I can see our new variables are in there. We've got our log variables. Of course, we could have used a different table. We could have gone in there and already have used a table that had this data within it. This table, for instance, but we will stick with the table that we've created these modified variables upon. So let's go in and model. Remember, we can't actually report because we haven't actually decided on what model we're going to do. Let's do a simple generalized linear model. Now at this point, I chose to have the roles appear above my choice of model type. I have to pick a dependent variable. My dependent variable will be the variable that we've just calculated, which is that log quantity of beer on trade. And my independent variables, well, let's take a number of seasonal values, see if there's any seasonal impact, and then we'll take all of the other log variables that have been calculated. Now notice that the log quantity beer on trade does not show in this window. That's because you can set it so that whatever you pick as one role item does not appear in the other items itself. At that point, it generates for me the necessary GLM code, and it also gives me my options in terms of what fit statistics I might want to choose. An additional thing that I could do here, I can group variables. Now remember, we have males and females. Well, let's just run this first and let's have a quick look at it. So if we run the model, what do we get? We get an R squared. It's not particularly good R squared. They're not bad. Price spirits isn't significant. The own price elasticity is very weakly negative, but it's a small change. I'm not particularly impressed with that model. What I might want to do is actually assess that model. So by selecting this option over here, calculating predicted value and showing assessment plots, I'm actually outputting the tables, score equals predicted. I'm using an ODS output statement, and again I'm plotting it, and I can choose how many bins I actually want to use for the lift calculation. So I've changed it there, so I'm going to have 50. Let's just run that so we get an idea of this particular model. Looking at the model itself now, it's generated out predicted. Yeah, I can see I've got a reasonable fit, but it's not brilliant. So let's change that model and just do that by gender. Now notice I don't have to sort it. All I do is I say group by gender. This data is randomly dispersed throughout it, so let's rerun that. At this point we now get that same model, but for each of the males and females. Looking at the data, we have females here, and interestingly the own price is positive. That's a very interesting result. And for males, let's check that is males, yeah, we can see that we have that's a negative. So for a 1% change in the price of beer within a pub, then we'd expect a 0.47 fall in the consumption. Let's have a look at our assessment. We come down a little bit. Yeah, there's our assessment for both males and females. Looks pretty good to me. So what we've got there is our model itself. Now what we want to do is we want to move on to producing a report based upon that. So I've just unticked the GLM option. Notice it tidies up the window, and we're into our report. And what surfaces on our report is that we've run our GLM model. Let's select that. We're going to select a report. We're going to enter a title for my particular report. Please enter comments. Analysis shows interesting own price elasticities. Do I want to add any comments on a particular variable? Well, yeah, I do actually. I actually want to add comments on the log price of on-trade beer. Let's put some specifics. Investigate this further. Do I want to email it? Well, that was one of my primary tasks. This email address field is not only a validation field, but it's also has a regex expression for a valid email address. So you'll notice that the requirements doesn't actually fill out until we get to the point where we have a valid email address. So let's run that, and that effectively sends out the email report, generates the report itself, as you can see over here, and then produces for me a very interesting elasticities of demand plot with the effect. So interestingly, price of wine has a negative impact. So if price of wine goes up, consumption of beer will fall. Price of spirits, different effect between males and females. Off trade, that's as you'd expect. If the competitive product increases in price, then the consumption of beer will in pubs would actually go up. We've already looked at the own price elasticities there, and household income, that's also an interesting effect. And we do see some seasonal changes as well, depending upon when the when that change might occur. So I've quickly started up my Outlook. You can see that the email has been sent to me, and we receive it as a PDF, so we can see the analysis of the results itself. We can see some interesting comments, and we also get the SGplot procedure. So this particular task useful for the purpose of calculating the elasticities of demand of alcohol consumption within the but it could be used for so much more. We can of course go back. We can select our data tab, and we could pick any table that has which is a laser table. So as I showed you earlier, I could now pick up a different laser table and carry out further analysis upon that, but it could be any table within that library. We generated this task for a particular reason, but we did find that we could load any data into the laser server and very quickly profile it and analyze that data. Thank you very much for listening.